So number one, remember back in the day when we just used to solve equations? Wasn't that wonderful?
When you have a regular positive or a negative or a multiplication?
Yeah, I know, see? So, yeah, you'll have one like this on the test, but just to review, and this should be easy. We've been solving equations so much. But 18 and 9, what is that, 27? Divide by 3. You're like, man, couldn't the final be this easy, all of them? Wouldn't that be fabulous? N equals 9. Now, I highly recommend when we're doing the final exam that you check your work. So you could always just plug it back in and see if you got it right or not.
3 times 9.
Okay. Number 3, Company A rents copiers for a monthly charge of $150 plus 6 cents per copy. Company B rents copiers for a monthly charge of $300 plus 3 cents per copy. What is the number of copies above which Company A's charges are the higher of the two? Now, this is worded really funky.
It sure is.
What I'm thinking is if we can find what I would call the break-even point, that's what they're looking for. And then anything above that would be Company A would charge more. Because once you find that breaking point, then Company A charges 6 cents per copy and Company B only charges 3 cents per copy. So once you find that middle ground where they're both equivalent or equal to one another, then that's when it's not going to be cheaper to go with Company A anymore. It's going to be cheaper to go with Company B. So notice what I said, break-even point, where they're equal to one another. So that's what we're going to write. So if it says 150 plus 6 cents per copy, mathematically, how would we translate that? Any ideas? Well, it's 150 plus 6 cents per copy.
So 0.06x.
Okay, so let's do that. 0.06x. Okay. Because we don't know how many copies, so that's what we're trying to find out. Now let's find when that equals Company B. Now, Company B is 300 plus 3 cents per copy. So let's see what happens when we solve this. Now, when you go to solve this, what are you going to do first? Okay, so do you want to move the 0.06x or the 0.03x? It does not matter to me. Okay, I agree. That's the one I would go with. So let's move this one. So negative 0.03x, we'll move that over here. And that's going to get us 150 plus 0.03x equals 300. And now I'll move the 150. And that's going to give me 0.03x equals 150. And divide by 0.03. So how many copies? That ends up being 5,000. So what this kind of translates to is if you're making less than 5,000 copies, then it's cheaper to go with Company A because you kind of have that flat fee and it's less expensive. The flat fee is less expensive. But once you hit the break-even point of 5,000, then it's going to be cheaper to switch and go to Company B. So it just kind of depends on how many copies you need to make. But yeah, the question, what is the number of copies above which Company A's charges are the higher of the two, is just worded really strange. But just remember, just set them equal to one another and solve, and that's kind of like your break-even point. Okay?
Hold up.
Number 5, x less than -3 or x greater than 5. Okay, so solve the compound inequality, express the solution using interval notation and graph. Now, luckily, we don't have anything to solve. It's already solved for us. So let's graph, and we're going to graph on the same number line. So -3 is down here, 5's up here somewhere. Ooh. So we need less than -3. So less than -3 would be an open parenthesis facing left, and we would shade left because we want less than -3. And then greater than 5 would be an open parenthesis going to the right and shaded to the right. Now that word or is really important because you can be either less than -3 or greater than 5. Okay, you can't be both. If that word or was and, how would that change our answer? Well, if it still said x is less than -3 and x is greater than 5, are there any numbers that fit both criteria at the same time? Can you be less than -3 and at the same time greater than 5? No. So what would your answer be if that word was and? No solution. There would be no answer. So just, I mean, a lot of times people overlook those little words, but sometimes they make a big difference in your answer. So I don't think there's going to be any trick ones on the test, because if it's like this on the review, it'll be like that on the final. But I just kind of want to throw that out there, that if that happened to be the word and, we would say no solution, because you have to meet both criteria if it's an and. If it's an or, you can be this or that. So our interval notation, yes, there will be a U. Thank you for reminding me. I didn't finish reading all the directions. We didn't have to solve. We graphed an interval notation. The interval notation looks a lot like your graph. So if I've got an open parenthesis at -3 like that, my interval notation is going to start that way because that's the highest it can go on that part. What's the lowest it can go?
Forever.
Yeah, -infinity. So we would put -infinity with a parenthesis sign. And then the right side here, the lowest it can be is 5, and the highest it can be is positive infinity. And then we put a U in between to represent that the two of those united make up your entire answer. So that's your interval notation. Now, parentheses are used because we used parentheses in our graph. Had we had the squared off brackets in our graph, we would have used squared off brackets in our interval notation. Okay?
The square off bracket means equal to.
It can equal it, yes. If there would have been the little equal to, here, I'll just pencil that in. If this had been equal to, then that would have changed this to square bracket, and it would have changed this to a square bracket. Okay? We always have parentheses around the infinities because you can never equal infinity. So if you have infinity, that is always a parenthesis. All you have to worry about is the number. Can it equal the number or not? All right, let's look at 7.
So far, so good.
Feeling all right so far? Good. 7. Absolute value 6x plus 3 is less than 5. There we go. Okay, so on this, whenever you're talking about absolute value, we have absolute value less than 5. So what's happening is we have, if you try to think of it visually on a number line, absolute value, if the absolute value is -5 and we want it to, or I'm sorry, if the absolute value is 5 and we want it to be less than 5, that means graphically we are getting closer to 0. It's a very bad arrow. Still a bad arrow. Okay, not much better. So that absolute value, we're getting closer and closer to 0, because that's what absolute value means, distance from 0. So if it's less than 5, we're getting closer and closer. The reason why that's important is because we use that idea to write two inequalities to help us solve. So what's inside the absolute value symbol can be less than 5. Okay, that's this arrow right here. And then how would we mathematically interpret the left-hand side of that arrow?
Change the sign.
what's inside your absolute value symbol has to be greater than. So here's your two inequalities that you have to solve. Now the way that you can remember what you're writing is I just write it once. I drop the absolute value symbols and I write it 6x plus 3 is less than 5. And then the other one is 6x plus 3, but then I opposite and then opposite. You can think of it that. I reverse my symbol and I opposite my number. So that's one way that you can kind of look at it and see. Your formula sheet also kind of gives you a little absolute value section. And you'll see on there, if it says less than, it'll have these kind of two scenarios on it. But there is a spot on your formula sheet that could help you out. Once you're here, you just solve both of them. So I'd have to subtract 3 from everything. And I'm going to end up with 2 answers in the end. So 6x is less than 2. 6x is greater than negative 8. And divide by 6. So that's going to give me x is less than 1/3. Oops. And this is going to be x is greater than negative 4/3. And it does say right in interval notation. So if you think of this as a graph, and sometimes when I write interval notation, even though they don't tell us to graph, I find it helpful to graph. I just think it makes it easier when I am graphing. So if I just visualize a graph, I have negative 4/3 down here. I have positive 1/3 up here. I have to be greater than negative 4/3, and I have to be less than 1/3. So I'm falling in between here. So my interval notation would be negative 4/3, comma, 1/3, surrounded with parentheses. I don't have to worry about anything union because I don't have two separate pieces. They're coming together, and so it's just that section in between. So interval notation is negative 4/3, comma, 1/3.
The negative.
Okay, number 9 says determine whether the graph is the graph of a function. So it's been a while since we talked about functions, but remember if you're given a graph, I'm just going to sketch one. I'll try to just sketch that one. Okay. If it is a function, then it passes what we call the vertical line test. And the vertical line test means I can draw a vertical line anywhere through my graph, and I'm only going to touch the graph one time.
That makes it a function.
That makes it, this is yes, it is a function. Now, if this was turned on its side, yeah, if we had something like a graph that was sideways like this, and we went to do our vertical line test, see how it hits the graph in 2 places? Not a function. So it can only touch the graph in one place and still be a function.